let's straight away jump into the topic. What's the topic which we are going to deal or discuss is motors, right? As I always say this, an important aspect of it, most dynamic system in the world is a power system. Why it is called the most dynamic system is quite simple. If you take a mobile, if you take a t-shirt, if you take laptop, this is manufactured when the manufacturer want to manufacture it. It's consumed when the consumer needs it. In between, there is a beautiful thing called storage, right? Either it's a two-wheeler or a four-wheeler, it's a bike, electronic items, food, whatever it is, anything and everything could be stored between the generation and consumption. And beauty of electrical power system is it has to power has to be generated and consumed at the same moment, right? Here, at least we can claim that electricity cannot be stored economically, at least as of now. So the generation and consumption has to take place at the same instant. This makes the power system most dynamic in the world. In such a power system, one key element which converts the electrical energy into mechanical energy is a motor. That's a super duper equipment which we are going to talk about. And probably let's ask this question, like means was saying other equipments or a substance, food, electronic items, gadgets, whatever you are talking about, which can be manufactured when the manufacturer is interested and it is consumed when the consumer needs it. But unfortunately, electricity, we do not have that sophistication. It has to be generated and consumed at the same moment. What could be the biggest challenge because of this? I need a mobile, I'm going to shop and I'm buying it when it is needed for me, but it is not really manufactured at that instant. It probably has manufactured 6 months back in China, or probably this might be have manufactured in USA probably 1 year back. There is a time gap between when I need it and when the manufacturer manufactures it. There is something called in between storage. But when I need to switch on a light, when I need to switch on my fan, means what say, I'm needing it now. Like two aspects I'm looking at. Is it possible by the sources? When I say sources, it could be the generating utility, whether they can generate it probably 3 days back or 3 years back or 3 months back, and means what's waiting for Selvakumar to switch on his fan or a light probably 3 years down the line or 3 months down the line or at least 3 minutes down the line? Absolutely no, right? Everybody agree that, like means what say, just like how my mobile manufacturer, when like he has manufactured it, I am going and buying at my will. Electricity utility cannot say that, or the generating utility cannot say that, okay, Selvakumar want to switch on the light or a fan probably 3 months down the line or 3 weeks down the line. So I will generate the electricity and keep it safe and let Selvakumar use it when he needs it, right? So what's the biggest challenge? What's the biggest challenge because of this? Like I want to hear from you, just stop the slide just to get some feedback, some answers from you. Electricity cannot be stored. That's the reason why we are facing the problem. But technically, what's the electrical biggest challenge which we need to have for the electrical engineers? And probably we have to be proud of electrical engineer, because if you take anything else, they are not handling that dynamics. As a power system engineer, as electrical engineer, we are handling such a dynamics, right? Maybe not full part, at least we have a small role to play as a part of this electrical energy. I cannot really means what say, like if I need an electricity for my switch on the laptop, switch on the light, switch on the fan, means what say, shall I say that electricity utility, those who are responsible for it, generating the electricity, can generate the electricity probably 3 days back and probably store it or do something and deliver it to Selvakumar today at this moment when I am delivering the lecture? Means because of this, do you think that only the losses are going to increase? Absolutely no, right? Let me probably go a little more deeper into this. Let me go deeper into this. Let me ask a very, very simple question. At this moment, assume that I have a 10,000 megawatt demand. At this moment, assume that like it's probably a country or a state or electricity utility or a standalone island, whatever it is. 10,000 megawatt is my generation. And I have 10,000 megawatt generation at that instant. When I say demand, I mean load plus losses. Don't ask me where is the losses. When I mean demand is like load plus losses. Load plus losses is 10,000 megawatt. Generation is also equal to 10,000 megawatt. My frequency is 50 hertz at this moment. And I'm suddenly switching on some 200 megawatt load to the system. Hope you are able to get my questions. 10,000 megawatt demand, load plus losses is 10,000 megawatt. 10,000 megawatt is my generation and frequency is 50 hertz. Before I suddenly bring in 200 megawatt load to the system. And I'm bringing 200 megawatt load to the system without notifying artificially with an artificial intelligence or something to the system. What I mean, when I'm switching on light or a fan or a refrigerator or an air conditioner or my television, I am not calling the electricity utility and saying that I'm going to switch on a light or a fan. Please ensure that means or say you generate the additional 100 watt which is needed for me. Right? I never ever inform the person who is responsible to generate the electricity at the moment. Right? I'm just like that increasing when I need it, and how complex it is for the utility, those who are responsible to generate the electricity and meet the demand instantaneously. So why I am saying this, because like I used to probably live in a remote city or village, which you can call in south part of India. Means what, say if there is a gap between producing tomatoes and consuming these tomatoes, this tomato price probably rises to 100 rupees per kg in the previous week, and that next week it goes down to 2 rupees per kg. The equipment or the product or the food which you are consuming, which can be stored effectively, the price is volatile and it is jumping from 100 rupees to 5 rupees, like means what, say there is like 20 times a change in price, even though the commodity could be saved or stored. And we are talking about something, electricity, which cannot be stored. And as I told, like means to say, I am not informing also probably some other demands which could be predictable. When I say like means to say, what's the wheat which is needed for the next 10 years or like next 6 months, it's predictable. But like electricity cannot be predicted. Electricity demand cannot be predicted. Even there is probably a statistics, if you go depth, 1% change in the temperature, 1 degree Celsius temperature change. Like I have predicted 40 degree ambient, but unfortunately that time it is just 41 degree Celsius, or it is just 39 degree Celsius. That can change the electricity demand by 2%. And countries like when India, when I am talking about 200 gigawatt, it is 2%. It is not a small value. It is 4,000 megawatt. Right? And probably the operators, electricity generating utility, those who are responsible to meet the demand when it comes is, I mean, so say, not really having a control over the loads, right? They cannot really control over when Selvakumar is switching on his light in his home. He cannot control when I am switching on my fan in my home, right? But when I am switching on the light and fan, at least 99.9% of the time, the fan is running and the light is glowing. And I guess my question is probably straightforward, how it is related to the today's topic, motor. So like 2 aspects which I'm going to talk today. First aspect of it, when such a demand increases from 10,000 megawatt to 10,200 megawatt suddenly without a notice, what happens at this moment instantaneously, and how my squirrel cage induction motor, which is running in the remote villages, maybe 5 HP or 10 HP, or probably the motors which are running in an industry, is helping this dynamic system when such a sudden increase in the load. Hope the question is clear. When such a sudden changes happens, how the system or how the squirrel cage induction motor, which is running across the system, is going to help this scenario. So means when the demand is increasing from 10,000 megawatt to 10,200 megawatt, still remember the generation remains 10,000 and probably the demand is 10,200 megawatt and frequency falls, but whether the additional 200 megawatt is met or not. Additional 200 megawatt is met or not. If it is met, from where it is met? Who has supplied the additional 200 megawatt? And probably means you can understand like the energy neither be created nor be destroyed. Means when I'm adding a 200 megawatt, which means like this 200 megawatt, I'm trying to convert this from electricity to a heat, electricity to an aerodynamic energy, electricity to mechanical, electricity to cooling, whatever it is. At the same moment, who is generating that equivalent 200 megawatt? Why my frequency is falling? How much my frequency is falling? How the induction motors helps preventing further reduction in the loss frequency. How my squirrel cage induction motors, which are running, prevents further reduction in the frequency. How they helps during the situations. Right? These are all probably some topics, and I guess like I'm going to talk a lot on this with respect to giving all the answers way back. Probably in the scenario session, which is going to come on back to basics, I guess like August 14th. That is on second Saturday of this next month, of course, August 14th. I am going to talk about. We will go and probably we'll deal more into this. Right. Let's start with the question. What is a motor? What is a motor? What is a motor? And why do we need motor? What is motor and why do we need motor? So I used to say this, like, means to say electrical energy is neither natural, it is not end use. Electrical energy, if you take, it's not naturally available like solar or wind. And you cannot use the electricity itself directly, right? Unless otherwise, means to say if you want to kill somebody, like you cannot use electricity as electricity itself. So then like why do we need an electricity in between? This is efficient, environment friendly, economic energy transfer. If you want to transmit the energy from one place to the other place economically, efficiently, environment friendly, then you need electrical, right? So what the motor does, or like why electricity is so famous? It's a flexible form. You can convert from any form to the electricity, and you can convert the electricity to any other form. That's the reason why the electricity is so popular. So what's the advantage is a flexibility, and it has like efficiency, economy, and so on so facts. So having said that, what is the motor? Motor is a device which converts the electrical energy to the mechanical energy. And probably let's go back and ask this question. When motor is converting the electricity to mechanical energy, electrical energy to the mechanical energy, is it consuming only real power or is it consuming something else also? Is it consuming only real power or is it consuming something else also? All right. It's consuming real power. It's consuming reactive power. That's what we say generally, right? Now let's ask the next question. What's the average value of reactive power? What's the average value of the reactive power? Real power has an average. Like draw the voltage and current waveform for pure resistive load. Draw the power waveform also. Find out the average value for that. You definitely will have an average number for that. That's what we call 5 megawatt, 10 megawatt, etc. It's all average numbers. But if you take a pure sinusoidal voltage source and an inductance, draw voltage, current, and power waveform. What's that power? You know, that's reactive power. And ask the question, what is the average value for it? What's the average value for reactive power? Shall I get some answers in chat? What's the average value for reactive power? Thanks, Raja. It's 0. Average value for the reactive power is 0. When average value is 0, how can I claim that reactive power generation, reactive power consumption? How can I say that induction motor not only consumes real power but also consumes reactive power when the reactive power average is 0? Right? Of course, let's keep all the questions. Let's keep all the questions. Right? And now one important question, at least we have answered. Motor is a device which converts the electrical energy to the mechanical energy. While doing so, it consumes the real power. Obvious, that's the electrical power which converts into mechanical power. In addition to that, it draws reactive power also. And while drawing reactive power, like what are the problems can happen, like voltage drop, it increases the losses, it increases the upstream equipment loadings, etc., etc. Now let's ask another question. If I want to reduce or eliminate the reactive power consumption of an induction machines, what are the methods which I have? What are the different methods which I have, or what are the logics or the possibilities which is available to eliminate the reactive power consumption of an induction motor? Induction motor anyway it's going to consume reactive power, but what are the methods which I can supply the reactive power to that induction machine nearby, so that this induction machine doesn't draw the reactive power from all along the way from the long remote grid? When I say remote grid, it could be a remote generator which is probably connected 200-300 kilometers away. And you might be well aware, real power can be transmitted over long distance, reactive power cannot be transmitted over long distance. All right. So you can have a capacitor bank that could be connected at a motor terminal itself, or that could be connected at a switchgear. It's a group compensation or an individual compensation. Anything else? You can do probably variable frequency drive. You can have a variable frequency drive. The input power factor of the variable frequency drive is unity. Your motor draws the reactive power from the variable frequency drive, but this variable frequency drive do not draw any reactive power. Do not draw any reactive power from the upstream. Probably technology is available in the variable frequency drive. Go to our YouTube channel, watch VFD modeling using ETAP 19.5, or go to our LinkedIn power projects page. Put like Tech Thursday hashtag power projects. I guess like Tech Thursday 02, where I have elaborated like means what say how I mean what say or why the variable frequency drive doesn't draw any reactive power from the grid. Right. So is there any other options? Probably you have another option also. You can convert this means what say slip ring or a squirrel cage induction motor to a synchronous motor. You can convert SCIM, squirrel cage induction motor, or a slip ring induction motor to a synchronous motor. If you're going for a synchronous motor, it is just not you're eliminating the reactive power consumption, you will be able to generate the reactive power also. Synchronous machine can generate reactive power, consume reactive power. It can be like neutral, neither it's in floating, neither generates nor consumes reactive power. It can be like over excitation, under excitation, or normal excitation. And it can be used to control the power factor. It can be used to control the voltage. It could be used to some other purpose, right? Having said all those things, synchronous machines efficiency are probably the synchronous machines advantages, like it's able to maintain voltage, it has a capability to maintain power factor, in case needed it can support reactive power, etc., etc. Despite of that, why squirrel cage induction motor? Let's ask that question. Why squirrel cage induction motor? If you have an induction motor, you can forget about the maintenance to an extent. So how can I say that? I basically coming from an agriculture family, and I know since my childhood, probably the induction motor 5 HP motor, 3.7 kilowatt motor, which is running in my well, we have never done a maintenance for 5 years or 6 years. Once in 5 years or once in 6 years, probably because of the voltage or because of some other issues. That motor is protected by a fuse. You can understand that means single phasing is possible, right? And probably means was this winding will fail, and probably means was we will take this motor to a nearby rewinding shop, or probably the rewinding person will come to our home itself to rewind this, and probably means was this motor is put in service back, and it will run for the next 5-10 years, right? So low maintenance is the key advantage. Low maintenance is the key advantage of squirrel cage induction motor compared to any other motors. All right, fine. So why squirrel cage induction motor? It's rugged, it's low maintenance, it's cheaper, right, compared to other stuffs. If you take a synchronous machines, then probably means you have an excitation systems, you need to do the maintenance, cost is expensive. Beyond that, there is another biggest problem when you will be facing in the synchronous machine is you need to maintain a synchronism. What I mean by that, you need to do the transient stability. You need to check for each and every fault whether this machine is stable with respect to grid or not. Right? You might have heard some terminology called critical clearing time, etc., etc. So coming back to this, so why we are not really using synchronous machines, though it has like reactive power control, voltage control, or a power factor control, it has an edge, etc., etc., etc. Because of its maintenance, because of it's not rugged. But despite of that, there is another issue which you need to really look at. You need to really worry about the stability. What I mean by that, whenever you have a synchronous machine, the synchronous machine has to always run in synchronism. If it is losing synchronism, then it goes out of step. So probably means whenever you have a synchronous motor, probably you need to do a transient stability. In addition to the generators, your motors also will lose the synchronism. You need to ensure that the generators and motors or any synchronous machine is operating in synchronism with the grid, right? All right, and probably moving to this squirrel cage induction motor, low maintenance, rugged, better efficiency, and probably let's ask one more question. Like means what say? Then what's the biggest drawback of induction machine? Is it drawing a reactive power? Power factor is poor. Means as upstream equipment loading it is increasing because of a poor power factor. Draws a more current, draws a higher starting current. These are all the drawbacks. And how to probably overcome all these things? How to overcome all these things? I guess like I mean what say starters, and I guess like I mean what say there are two aspects not really to confuse. One is a soft starter, other one is a variable frequency drive. The purpose of the starter is just to start the motor with reducing the starting current, full stop. Done. After the motor has picked up its rated speed, starter do not have any role to play. Whereas variable frequency drive is not a starter. It has an additional advantage of a starter. It has an additional advantage of maintaining input power factor. But the main purpose of the variable frequency drive is not that. Variable frequency drive maintains or controls the speed for a speed control applications, and it drives the energy efficiency. If you ask any energy auditor, probably they say like means what say where the energy is leaking in any industry, and predominantly means what say lightly loaded induction machines are probably the culprits just next to your heating applications or HVAC applications in the energy loss in the industries. Lightly loaded induction machines are the culprit for your energy consumptions and energy loss. So there, like when you have a continuous fluctuating loads, if you're going for a variable frequency drive, that probably reduce the energy consumption, and that's the application of the variable frequency drive. Not really to confuse variable frequency drive and the soft starter. And when it comes to the soft starter, there are many types, right? Like direct online start or star delta starter or a soft starter. Variable frequency drive has a feature of a soft starting, but that is not really meant only for the soft starting. That's what I have told. And you have talked about like LRS starter. I'm not really sure if you have talked about means if you're in a cement industry or something, you appreciate this LRS starters, liquid resistance. You might be talking about FCMA starters. Yeah, FCMA starters also. And I guess like one of our colleague who has written recently a blog about, I'm not really sure whether it is there. You can probably go to this equipments and you can watch like some articles related to that. Motor, it is protection. Okay, one article. All right, starter. Okay. Some FCMA starter, we have done a project recently, like for a pumping applications, and LRS starter, right? Like you can very well watch this to better understand like what's the different starter, what's the purpose of it, and why do we need FCMA starter or LRS starter instead of soft starter at that place, and so on and so forth, right? All right, coming back to probably the protection, right? I guess like I mean, so you can go to the motor and you can really look at one small article which is available on the motor, which you can probably read, right? Let me ask one interesting or probably a simple question. What is type 2 coordination? What is type 2 coordination? What is type 2 coordination? Right? So type 2 coordination chart is the one which we should not really miss it when it comes to the protection. Let me quickly put some type 2 coordination chart. Right? So some images let's bring for some motors. Right? That has an advantage, like you cannot, like what's the minimum capacity of the motor, you know what is the maximum capacity of the motor, what is the type 1 coordination and what is the type 2 coordination, and why we have to go for a type 2 coordination. So when you have a type 2 coordination, you are protecting the protective equipment as well as you are protecting the equipment which is to be protected. Let me repeat my statement. In type 2 coordination, you are protecting the equipment which is to be protected, which is motor, and you are protecting the equipment which is protecting, which is circuit breaker or whatever it is. So that's basically the purpose of type 2 coordination. And type 2 coordination, you have a clear chart for what capacity motor, like what is the protection device which needs to be selected. And like one interesting fact which you need to really understand, nowadays the motors are like, very extremely high energy efficient, especially at the low voltage. Energy efficient motors comes with a higher X by R ratio. They also come with higher starting current. And you might be aware, we are talking about energy efficiency very rigorously. And energy efficient motors, what we are talking about, this energy efficient motors also comes with a drawback. That is high starting current. Typically, we talk about 5 times, 6 times, 7.2 times the starting current. But if you go for an energy efficient motor, the starting current could be like 11 times, 12 times also. Sorry. And when probably you are choosing an MCB, you have to be literally clear about what's the MCB which you are selecting, right? You might be aware, like there are 3 types of, at least the very common. All right, I guess like this could be an image which gives what is type B, what is type C, what is type D, what is overload, what is short circuit, protections, etc., where to use, etc., etc. So you have to be literally clear, like what applications, what type of MCB which you are using. So what I mean by that, for a resistive load, you can use maybe B type. For semi-inductive type, you can use C type MCB. And probably if it's a heavy inductive type applications, you have to go for type D. Thank you all. Thank you so much. Have a great day.